Okay, today we're going to talk about how to get a free shunt resistor. It's very simple and easy. We can make it our own. The thing is with these shunt resistors, you don't have to have a meter that can read in milliohms, because we're going to do Ohm's law solve for the resistance. Now, when doing this, you want to have a circuit something like this. This is a 1.5 volt battery, it could be AA, C size battery, whatever. Then it goes to two 6.2 ohm resistors in parallel to make 3.1 ohm resistor, which will get almost about like half an amp. Then you have your shunt, which is right here. The shunt's right here, this part here, this between there and there, right here, that's where our shunt is. And across the shunt, in parallel, going across it, you have a voltmeter, and that reads the current in voltage. This is also called current to voltage converter. Anyway, we can start by hooking up our meter. Put it on the range right here. We're going to measure it, have it set to 500 milliamps. Since I don't, to make sure, if you're going to do it on a power supply, make sure, only thing, make sure if you're going to do it without a resistor, make sure it's constant current. This power supply is constant current, so I don't have to have a resistor. If it ain't, you'll need a resistor. Now, next thing is we'll put this one here. I'll clip this one. And we're reading about 174 millivolts. Now, on our board here, it says right here this resistor here is the shunt resistor. R equals V times 2. Since you multiply it by half a volt, anytime you multiply the number by half, it divides it by 2. So if you multiply it by 2, you actually get what the resistance R is. We multiply the voltage by 2, so it will take 173.172 times 2, 346.4. I rounded it off to like 400 millivolts. You can do it that way or whatever. Also, these type of wires, they have a current limit. You have to limit the current on it. I think it'll work at 5 amps, but the thing is, you shouldn't be running all the time at 5 amps, because it does heat up. Now, you probably want to know how to use this shunt resistor. Well, if you're going to measure current, you just put, for the current, you tell it be V over R, which will be your voltage that you read from this meter here, over R, your resistance. You probably this circuit probably confuses you a little bit, so I'm going to change it. Since this is just a testing circuit, why don't we just put a block diagram hang on. Where'd I put my marker? That's power supply unit. Then we have right here load. You see our shunt. Then down here you'll have a meter. And this gets all the way, makes it back to here. Like that. And that's how it works. You put your, it's just like an amp meter. This here could be just like an amp meter. It can be like connected in series with your load. Now, let's say we have height in the meter so we don't see the current reading. We can let's set it to 1.5 amps. So then you take this, take your 0.4, times it by 1.5, and we get 600 millivolts. Which you should turn it this way. We can say 600, 500 will work. And you see we got on the meter right there. Now let's say you want to measure, let's say you measure it from here and there, and you want to know what the current is. Let's say we set it to 3.5, 2.58. I'm going to see if we can get that value from that number there, which is, well, actually this time it's 1.3 volts. Instead of in millivolts, it's in 1.3 volts. It's starting to heat up a little bit. I feel it getting warm. There you go. You have your current there. It matches that close to it. It's about 200 milliohms off, millivolts off. And what you want to do is first you want to calibrate it, and then calibrate it by putting that, like I said, with that other circuit with the battery and 6.2 volts on it. You calibrate it like that, and you want to write it down. It's resistance, so you don't have to look, so you don't have to calculate it no more. You can put it on this like I did here, 0.4. 0.4 mil, 0.4 ohm, 3 amp. Of course, I now set 3.57. It probably works in any kind of amperage. Just gotta be careful. I watch it and just not have it used like that constantly on the high amperage, of course. Now, this here is gonna also. I'm gonna use something like this in my fuse I'm building. I'm building an electronic a circuit that will use a comparator. Hopefully, a comparator. If not, if that fails, we'll try using Arduino. I like to try to use not use Arduino. Arduino's kind of big and stuff, and it's more expensive than just a comparator. You get a comparator, it's cheaper. You get a comparator and resistors. I hope it works this voltage. It should. I don't see why it wouldn't. So you have to watch, subscribe, see about waiting for that video. And I hope it works and everything. This is pretty fun and simple to make. It's a lot cheaper than buying a resistor and have to wait for it to come in the mail and stuff. You can just make it on your own. I was going to use automotive wire, but that didn't. But you know, didn't have money to go get it, so we got this Cat 5 cord. This is actually from a Cat 5 cord, network cord. This resistor is made out of 2 wires on it, and then I soldered them both together. To the end there, and then one wire goes from 1 liter resistor, and the other wire goes to the other liter resistor. Well, that's it for now. So I hope you enjoyed this video. Thanks for watching. Hope you like it.